Welcome to Lesson 5 of our Chemistry from Zero to Hero series. Today we're becoming separation scientists and learning practical methods to separate different types of mixtures. From purifying drinking water to extracting metals from ores, separation techniques are essential in chemistry, industry, and daily life. Separation is crucial for purification, analysis, resource recovery, environmental protection, and medicine. The method chosen depends on the mixture type and properties of its components. Remember, we separate mixtures using physical methods that exploit differences in properties like size, solubility, density, boiling point, or magnetic behavior, while chemical methods are for compounds. Let's start with simple separation methods used for heterogeneous mixtures where components are visibly different. Handpicking involves manual separation of different components based on size, color, or shape differences, like removing stones from rice. Sieving separates by particle size using mesh, like flour sieving or sand and gravel separation. Magnetic separation uses magnets to separate magnetic materials, like iron from sand. Winnowing separates by weight using air currents, like grain from chaff. These methods work because components have obvious physical differences. In daily life, we use sieving for flour, handpicking for fruits, magnetic separation for finding pins, and various methods in recycling and household tasks. Now let's explore filtration for separating insoluble solids from liquids. Filtration works by passing the mixture through a filter medium where solid particles are too large to pass through and get trapped, like making coffee or tea. Simple filtration uses filter paper in a funnel, with the solid collected as residue and liquid as filtrate. Sedimentation and decantation involve letting solids settle then pouring off liquid, used for muddy water or rice cleaning. Applications include water treatment using sand beds, laboratory isolation of precipitates, brewing clarification, swimming pool cleaning, and vacuum cleaner filters. Advanced methods include vacuum filtration using suction, centrifugation spinning at high speeds, and various membrane filtrations for different particle sizes. For separating soluble solids from liquids, we use evaporation and distillation methods. Evaporation involves heating to dryness to recover solid, like getting salt from seawater, but cannot recover the liquid. Distillation involves boiling and condensing to recover liquid, used for water purification and alcohol production. Simple distillation separates liquids with different boiling points. Fractional distillation with a fractionating column separates multiple liquids with close boiling points, used in petroleum refining. Steam distillation uses steam for heat-sensitive compounds like essential oils from plants. Industrial applications include petroleum refining separating crude oil into gasoline, diesel, etc., alcohol production, water purification, and perfume industry extraction. Nature's water cycle is a natural distillation process. For complex separations, especially of dissolved substances with similar properties, we use advanced techniques like chromatography and crystallization. Paper chromatography separates components based on different solubility in solvent versus attraction to paper, used for ink analysis and plant pigments. Thin layer chromatography uses coated plates for drug analysis. Column chromatography purifies compounds using different attraction to packing material. Gas chromatography separates based on volatility for forensic and environmental analysis. Crystallization forms pure crystals from solution by evaporating or cooling, producing very pure products like sugar and salt. Sublimation involves solid directly turning to gas and back, used for purifying iodine and camphor. These methods are essential in forensic science, pharmaceuticals, food industry, and research. Separation techniques scale up to major industrial processes. Water treatment uses sedimentation, filtration, distillation, and advanced methods for clean drinking water. Petroleum refining uses fractional distillation to separate crude oil into gasoline, kerosene, diesel, and other products. Mining and metallurgy use crushing, froth flotation, magnetic separation, and electrolysis to extract metals from ores. Food processing uses filtration for juice clarification, distillation for alcohol, evaporation for milk concentration, and crystallization for sugar production. Environmental applications include air pollution control with electrostatic precipitation, water pollution treatment with biological and filtration methods, and waste recycling with magnetic separation and manual sorting. Emerging technologies include membrane filtration, supercritical fluid extraction, molecular sieves, and advanced chromatography methods. With so many separation methods available, how do you choose the right one? Use a systematic approach starting with identifying the mixture type: solid-solid, solid-liquid, liquid-liquid, or gas mixture. For visible components, use handpicking, sieving, or magnetic separation. For insoluble solids in liquids, use filtration or sedimentation. For soluble solids, use evaporation or crystallization. For liquids with different boiling points, use distillation. For complex mixtures, use chromatography. Consider additional factors like scale, cost, time, purity requirements, safety, environmental impact, and whether you need to recover all components. Often, multiple methods are used in sequence. The key is analyzing mixture properties and understanding what each method can achieve for optimal separation. Congratulations on mastering mixture separation techniques. We've covered simple methods like handpicking and sieving, solid-liquid separation with filtration, solution separation with evaporation and distillation, advanced methods like chromatography, industrial processes, and selection strategies. Remember that different methods work based on different principles: size differences, solubility, boiling points, magnetic properties, and molecular interactions. These separation techniques enable purification, resource recovery, environmental protection, and advanced technology and medicine. In our next lesson, we'll explore atoms and molecules, the fundamental building blocks of all matter. Keep observing separation processes around you and appreciate how they make modern life possible. Thank you for learning with Silent Reader Chemistry.